Hello everyone, welcome back to my YouTube channel. So in previous three videos, I uploaded a model question paper of Introduction to Electrical Engineering, that is Module 1 and Module 2 solutions. So now without wasting time, let's move on to the Module 3 solutions of model question paper of VTU for the subject Introduction to Electrical Engineering. So just observe the question paper. They asked constructional details of DC generator with a neat diagram. So that is for 8 marks. For 8 marks you need to write. Similarly, they asked you to write a derivation of armature torque developed in a DC motor for 8. So you can easily score 16 marks with the help of these two theory questions. So that you can at the end I'll tell what are the important theory questions that will comes in a module 3, so that will really helps you to prepare for the examination. So before that, can see the question number 5a with a neat diagram explain the construction of DC machine. So you need to draw the construction, that is you need to draw the constructional future diagram of DC machine or DC generator or DC motor. So you have to mark the parts neatly because they asked it for 8 marks. So minimum of 3 marks that will be for diagram. And again, if the diagram is wrong, explanation is right, you'll get, you may have possibility to get a 0 mark. So that draw the diagram neatly. And you need to explain the parts. So what are the parts you have to explain? So 5 main parts you have in this DC machine. That is the first one is yoke. So you need to write these points. Yoke, that is outermost cover of DC machine, so that the insulating materials will get protected from harmful atmospheric elements like moisture, dust, and various gases. Okay, so now, and also it provides mechanical support to the poles, and this is iron body that provides low reluctance path to complete magnetic circuit, and it is prepared with the help of cast iron because it is cheapest and provides low reluctance path. So if you are having a low reluctance path, it will provide you maximum area of cross section for the flux. So that for the large machines, you'll be using rolled steel, cast steel, and silicon steel that will be used, that will provide again the low reluctance and good mechanical strength to the machine. So you need to write these points. Outermost cover of the DC machine, it protects the insulating materials from moisture, dust, and various flue gases, and it will provide a mechanical support to the pole. Material cast iron, rolled steel, cast steel, and silicon steel. Similarly, the second important part is poles. So you can see here the pole which is divided into two parts. One is pole shoe. You can see this is pole core, and another one is pole shoe. This part you can call it as pole shoe. The pole core, that is nothing but this pole core which carries field winding so that it produces flux, and this pole shoe, it will give a direction to the flux from air gap to this armature winding. Okay, so through the air gap to armature core, it will give a direction for the flux that produced from pole core. Okay, so this is about poles. Similarly, the next part is field winding. You can see the field winding which is wound to the field, sorry, which is wound to the pole core of DC machine, so that once after giving the supply, that pole core that will be act as electromagnet and it produces electromagnetic flux, so that The coil which is wound on the pole core is called as field coil, whereas these field coils are connected in series, you can observe. So this field coil that will be connected in series to form one field winding. By connecting field coils in a series, it will form field winding. And whenever the current that is passed through the field winding in specific direction to magnetize the poles and pole shoe, so that a magnetic flux is produced in the air gap between pole shoe and armature. So that you can also call this field winding as exciting winding. And material, so conducting materials that will be made up of copper or aluminum. Due to the current flowing in the field winding, the alternative north pole, south pole that will be produced. Similarly, next we'll be having armature core and winding. So armature core is nothing but you can see here the cylindrical shape. The cylindrical shape that will be mounted on the shaft. You can see here the shaft. This armature core is a cylindrical shape and it is mounted on the shaft of DC machine and it consists of slots. It consists of slots and on its on this slots periphery and also the air ducts to permit the air flows to armature for cooling purpose. And function of this armature core that provides housing for armature conductors. It will give a place for armature conductors and also it provides a path of low reluctance to the flux. Choice of material, it will be made up of cast iron and this laminated construction that is made up of, so that will be laminated. So this construction that will be laminated to reduce it from eddy current losses or else to minimize the eddy current losses. And the next is a very important point, that is commutator. So commutator, basically what happens whenever the supply which is given to the pole core with the help of field coils, also field winding, whenever supply that will be given to the field winding, the pole that will act as electromagnet and it produces electromagnetism property and hence it produces electrical flux. That flux is linking with the armature, so that armature that will be induces the EMF and that induced EMF is AC. So you need to convert that AC voltage into DC voltage. So to convert this alternating EMF to unidirectional or DC EMF, we can use a commutator. And this will always produces unidirectional torque in case of DC motor. And materials, and this commutator that will be made up of copper and insulating material between the segment is mica. Last part is brushes and brush gear. So if you are not writing about brush gear, that is fine, but you need to write about the brushes. Brushes that are basically stationary and resting on the commutator, on the surface of commutator. So the function of this is to collect the converted current, that is collect the current from commutator. In the commutator that converts AC into DC, so that to collect the DC current from the commutator and make it available to the stationary external circuit by using brushes. And materials, the carbon or graphite will be using it for the brushes. So this much of points you need to write in the examination. Just see once, you have to draw the diagram neatly. Once after that, you have to explain yoke, poles, then you have to explain field winding, armature winding, then commutator, brushes. Okay, so if it is for 8 marks, sometimes 3 marks for diagram, 5 marks for explanation, sometimes 2 marks for diagram, 6 marks for the explanation. Okay, and the next, a second one is derive an expression of armature torque developed in DC motor, that is for again 8 marks. Okay, so for this derivation, so first you need to write the definition of torque. The torque is nothing but a turning or twisting force about an axis, you can call it as torque. So now let us consider a wheel of radius r meter that will be acted by a circumferential force F newtons. If the wheel that will be rotating in a clockwise direction, force will be acting down. Suppose if the wheel that will be rotating in a anti-clockwise direction, in that case, the force that will be acted on upward direction. So that you are considering a wheel of radius r meters that will be acted upon by a circumferential force F newtons you are seeing in a diagram. So with the help of this, you are defining angular speed omega is given by 2 pi n by 60 and you are giving this as equation number 1. Once after defining the rotating speed, that is once if you are defining the speed of a rotor n rpm, then you need to get the angular speed omega 2 pi n by 60, whereas n is nothing but rotating, that is a wheel speed, rotor speed. So now you need to get the work done in one revolution. We know that work done is nothing but a force into distance traveled in one revolution. So that you can write force and distance traveled for one revolution, here it is 2 pi r. So that F into 2 pi r is joules. So first you are writing the definition, then you are considering a wheel with a radius and it produces the force, then you are defining the angular speed 2 pi n by 60. Once after that you are defining the work done F, that is force into distance traveled, that is F into 2 pi r. Once after getting the work done, you are defining power. Power is nothing but the rate at which work done, the rate at which work is done is called power. So that you are defining the power work done divided by time taken to complete one revolution of rotor speed. So that work done you already know F into 2 pi r, time taken for one revolution is 60 divided by n, so that P equals to F into 2 pi r divided by 60 by n. So you can rewrite it as F into R. So you can rewrite this as this F and R as a one group and 2 pi n by 60 as another group. Whereas F into R is nothing but torque and 2 pi n by 60 is nothing but angular speed omega. So that you're writing power P equals to T into omega in terms of watt. So to find the armature torque, you replace P by armature power, that is power developed in armature is given by Eb into Ia, and you're replacing T by Ta, that is nothing but armature torque, whereas omega you already know the angular speed 2 pi n by 60. So that where there is a P, you are substituting as a Pa, where there is a T, you are substituting it as Ta, so that you can get Pa equals to, I'll write it here, Pa equals to Ta into omega. Whereas Pa is armature power. Power developed in armature is given by Eb into Ia. So that Eb into Ia equals to Ta into omega. And also you know that Eb is given by phi z np by 60A. Phi z np by 60A. And also omega is nothing but 2 pi n by, sorry, omega is given by 2 pi n by 60. So Eb into Ia equals to Ta into omega is 2 pi n by 60, whereas Eb is phi z np by 60A, so that you're writing phi z np by 60A into Ia equals Ta into omega is nothing but 2 pi n by 60. Here 60 and 60 will get cancelled, then n and n will get cancelled. So rest of the part Ta is given by 1 divided by 2 pi into Ia Pz by A. So 1 by 2 pi is nothing but 0.159. So that you can write 0.159 pi into Ia Pz by A. So this much you have to write in the examination because they asked it for 8 marks. First you are writing a definition, then you are defining a wheel which has a radius r and it will be produces a force F. So once after that you are defining angular speed omega, that is 2 pi n by 60. After that you are defining work done, that is force into distance traveled. So after that power developed, work done divided by time, whereas work done is force into distance traveled, that is F into 2 pi r. and time is time taken for one revolution 60 by n. You are rearranging that, you can get P equals to T into omega. Once after that, you are replacing P by PA, armature power, that is power in armature, and T by TA, that is armature torque. So armature power or this power in armature is given by EB into IA, whereas EB equals to pi Z NP by 60A. By doing these all simplification, at the end you are getting torque equation, that is 0.159 pi into IA PZ divided by A. So now let's move on the question number 3 of module 3. So they asked one problem, that is, can observe, that is for just 4 marks. So what they asked you to calculate, you understand the problem carefully. So there is an 8-pole generator. So that generator we have, they're giving P equals to 8. 8-pole generator has 500 armature conductors. That is Z they are given, that is 500 conductors. And it has useful flux per pole, pi equals to 0.065 Weber. And they asked what will be the generated EMF, what is EG if it is lap connected. If it is lap connected is nothing but if it is A equals to P and it will be runs at N equals to 1000 RPM. So first you need to find generated EMF for this condition. Later what? You need to find the speed. What must be the speed? For this calculated value of EG, you need to find the value of speed by considering it as wave winding. So let us find EG now. We know that EG is given by pi ZNP divided by 60A. So here A equals to P because first case a lap connected. So that phi is nothing but 0.065 into Z is nothing but 500 into N they are given 1000 for this case. P you know that A equals to P. A and P will get cancelled. So that divided by 60 directly because A equals to P. So by calculating this, so let me give me a minute. So 0.065 into 500 into 1000 divided by 60. So you can get 541.66. So easy is 541.66 volts. So what they asked for the second case, for this same EMF, that is what must be the speed? What must be the speed which is to be driven to produce the same EMF, that is EG equals to 541.66 volts if it is wave connected. Wave connected is nothing but if it is A equals to 2. So you can use the same formula, that is EG equals to 5ZNP divided by 60A, whereas A equals to 2, later I'll substitute. So you need to find N. N is given by EG into 60 into A divided by 5ZP. So now we can substitute. EG is nothing but 541.66 into 60 into A equals to 2 for the second case. 5 they are given 0.065. Z they are given 500. These are constant parameters. P is 8. So now we can get the value of N. So 541.66 into 60 into 2 divided by 0.065 into 500 into 8. So you can get 249.99 RPM, 249.99, or that will be equivalent to 250 RPM. So this is the solution. For first case it is 2 marks. For second case it is 2 marks. Thank you. If you are having any doubts regarding this, feel free to write in the comment box. For the question number 6 ABC, I'll upload in the next video. Thank you so much. And don't forget to like and share as much as possible, and please subscribe to this channel so it will help a lot to us. Thank you so much. Thank you.